All right, so we're going to start talking about calculating the pH of different acidic solutions. Okay, so if we're given a strong acid and asked to calculate the pH, remember that strong acids dissociate 100% in water, and this means the reaction is super product favored. So Ka is going to be very large. So we're going to assume whatever the concentration of the acid is, that's what the concentration of our H plus ion is. So we don't need an ice chart because it goes to completion. So we can just plug in our concentration to the pH equal negative log of the H plus. So pH equals negative log of 0.00125. And that means our pH is and pH at 2.9. Okay, now, if we are given a weak acid, okay, and asked for the pH, we have the Ka. Ka is small, and we know that weak acids do not dissociate completely in water, so we're going to have to determine, based on our Ka, what our H plus is. So we need to ice it. So we're going to go through a couple steps. Let me throw the steps up, okay? So step 1, write dissociation equation. 2, ice it. Set up our expression, solve for x, and convert. First, let's write our expression. So we got Ka equals C2H3O2 minus times H plus. Okay, and that's over the concentration of the acid itself. Okay, so there's our expression. Says that we started with a 0.5 of the acid, which means we had none of the dissociated. So we're going to have minus x plus x plus x. So here we have x and x, and then we have 0.5 minus x. Okay, so now we're going to set it up into our equation here. So we got x and x on top, and then on bottom we have 0.5 minus x. And that's equal to our Ka, which was 1.8 times 10 to the negative 5. Now, Ka is very small, so I can go ahead and just cross that part out because I won't need it. So basically on bottom I'll have 0.5, so cross multiply the 0.5 times the 1.8 times 10 to the negative 5th. And we get 9 times 10 to the negative 6, and that's equal to the x times x, which is x squared. And then if you go ahead and take the square root, you get 0.003, or 3 times 10 to the negative third. Now that's your change, okay? So that goes in for all these x's. Well, we're really looking for pH. We just care about the H plus, which is this. So now we can plug in the concentration into our equation, and that's our pH. Okay? All right. Let's try one more problem. All right, so this one wants us to calculate the pH of 0.00125 molar HOCl, and this is the Ka, so you see it's not a strong acid, so we're going to have to set up our equation. So here's our dissociation equation. All right, and we're going to have to ice it. All right, so we started with 0.00125, 0 and 0, and then we're going to minus x plus x plus x. So 0.00125 minus x, x, and x. Okay, now when we write our expression for Ka, H plus times OCl minus over HOCl. Okay, so products over reactants. All right, and we're plugging in. I'm going to go ahead and simplify because you had x and x, so x squared. And then on the bottom, you got 0.00125 minus x. And that's equal to our Ka, which was 3.5 times 10 to the negative 8. Okay, so really, really tiny, so I can cross out my x. So I'm going to do 3.5 times 10 to the negative 8, cross multiplied by 0.00125, and I get 4.375 times 10 to the negative 11th is equal to x squared. Take the square root, and my x value is 6.6 times 10 to the negative 6th. Now the x is the concentration of my H+, so if I do pH equals the negative log of 6.6 times 10 to the negative 6, I get the pH, which is 5.18. Okay?